One, two, one, two, one, two. Let's increase the noise gate. See if we can block the noise of the fan. How about that? That's not too bad, is it? Not bad at all. Alright, hello everybody. My name is Raphael Malikian. This is my YouTube and Twitch channel where I am building in public, sharing my process, working on different healthcare and large language model, machine learning and artificial intelligence projects. Basically building in public. A brief introduction. I have 20 years of domain experience in the healthcare industry between the United Kingdom and the United States, including working as a family medicine physician and also bootstrapping a direct primary care startup and making a more definitive pivot into health technology these days. So this is the channel where I've been sharing my process, cooking up live online, cooking up live, building in public, and figure I'm working on nice projects anyway. And when I was a kid in school, I was never one to put my hand over my work and cover it. I've always thought that if you're working on something good, it should be shared. If you have a light, it should be placed high up to illuminate the place, not hidden underneath the table. That's the spirit with which I'm operating right now. For today's stream, I'm going to be working through a competition, a hackathon that I have enrolled in, which is a Google featured hackathon, which is the 5-day AI Agents Intensive Vibe Coding course with Google. And this is a 5-day online course developed by Google researchers and engineers, diving into building powerful AI agents from foundational concepts to production-ready systems. I'm going to be basically vibe coding workflows using natural language as the primary programming interface and learning how to create 10x agents by integrating tools, APIs, and multi-agent systems. And I'm going to be sharing that process here on the stream. So just get everything ready. Hope everybody's been doing well. I had a bit of a digital detox last week and stepped away from streaming and computer work. Did have to have my computer submitted or sent in for evaluation or for a check last week on Thursday, and I thought I wasn't going to get my computer back for weeks and weeks and weeks, and that gave me a little bit of I was like an addict. I was like, oh my goodness, how am I going to get my tech fixed? What am I going to do? And was really stressing out about it. But when I took it to the office for them to have a look at it, handed it in and said, okay, you can call me on my landline if you need to reach me, because I won't have my computer. Or I had to hand in my cell phone as well. And the individual who was checking the hardware said, oh no, just hang out. I'll give this back to you in about 45 minutes. So I was like, really? That's a win. So good to be back online again. I was actually hoping for more of a digital detox. There was a part of me that actually wanted to be away from my computer for a while to just reset, because I have been getting pretty obsessed and addicted to vibe coding. You know, I have an addictive personality, and I've noticed the analogy of trying to get my fix of vibe coding. I started ruminating on where am I going to get my tokens from once my subscription runs out, and I noticed some addictive type behaviors creeping up, where I was kind of dwelling on how am I going to get my next, where am I going to get my next subscription from? Am I going to have issues with getting tokens? Maybe there's a market for like vibe coding anonymous to help people not get totally swept away. That might not be a bad thing for our community. So, just getting my screen organized behind me. Had a nice day yesterday. I went out for a night drive. I asked my coding agent, what's a good thing to do that's kind of low pressure, chill, not overstimulated activity, where I could do something fun, basically, without getting too overstimulated and going to somewhere really crazy with loads of people, or, you know, high expectation environment. And my trusted agent recommended that I go drive on the beach. I was like, you know what? That's a pretty good idea. So got in the car at about 10 o'clock or so, and cruised down to, let me turn some music on. Cruised down to Santa Monica and drove along Zuma Beach, which was always nice. Haven't been there in many, many years. And what was nice about it, I really wanted to just drive as slow as possible along PCH. And I was like, you know, PCH very highly policed because lots of people drink drive there, and it's you know, quite a popular area. I was like, I don't want to get in trouble for driving too slow. I'm not driving through the middle of the desert. This is a very populated area. But as fate would have it, kind of bittersweet, which I'll go into more. I got to Santa Monica, started out driving up through Malibu and the Palisades, and I remembered, the Palisades fires had happened. And bittersweet, I saw lots of construction, lots of empty lots. But it was nighttime, so that kind of dulled the impact of it. But the nice part of that was, for about 10 miles, the speed limit along PCH was stuck to 25 miles per hour, and I've never been one for really speeding. Maybe a few times in my life I've gone over the speed limit, but for the bulk of it, I stick to the speed limit pretty strictly, to say it for lack of a better word. And just stuck at 25 miles per hour, cruising nice and slow through PCH while everybody was kind of racing, overtaking me, and just got to smell the sea air. And then kicked back in Santa Monica for a little bit. I had a pizza from Jimmy John's, and came back. It was a nice night out. I definitely feel better for changing the scenery. So let's get started. Let me open up the email from Kaggle, and we'll go through the steps. Where is it? Day 1 assignment. Last week was funny. I was trying to, was it last week or the week before? I was working on fine-tuning a large language model for my medical billing project. And it was taking a very, very long time, which is fine. So while I was sitting there waiting for it to work, I wanted to do something that wasn't using the computer, because obviously it was very GPU intensive. And I fumbled, actually, because I didn't realize how much, or didn't appreciate how much of my GPU OBS was going to use. So like OBS was using 3/4 of my GPU, and didn't leave much didn't leave very much there for didn't leave much there for machine learning. So I had to turn the machine off and then run it offline, which was frustrating because I really, really wanted to share the process but couldn't. And I don't have a second machine to stream on right now. I have a Galaxy S26 Ultra I'm waiting to set up. So once that's cooking, I'll probably be able to maybe stream with that. I don't know. Let me just get my ticker started. Have my ticker for the bottom of the screen, and also my CPU monitor that I've been using. Then I'll be ready to get started with the Kaggle challenge and sharing the process here for you. I think I can do that live. The whole point of this is sharing my process. So first I'm doing is just starting my ticker. So there's I have a ticker that runs along the bottom of the screen. I just want to start that. Okay, market ticker is running. So if I refresh my source here, it should pop up. Let's see. Should be there. Come on, dude. Do I need to pop out and come back into it? That's not working. It's not running. Right now I'm using OpenCode as my go-to CLI coding agent. That's better. Okay. Let's try that again. And 1, 2, 3. Boom, there we go. Okay, the ticker is up. But it looks like we don't have any stock prices. Market has not gone that bad, don't worry. So that's cooking. I'm also going to start my I have a GPU CPU monitor called Glances. I'm just going to fire that up. That's going to show up here my CPU and hard drive usage. API endpoint is completely down or broken. The server has a mock mode we can use instead. No, don't use mock data. I need a live source. So, ticker is down. It's the first call of affairs is the healthcare markets. We don't have any healthcare unless we can keep the lights on. His glances on up. Maybe I'll improve the way that Glances runs. The Glances minus GPU. No, it didn't like it. Look at that, beautiful. I need to start in server mode, okay. Glances minus W. Ping pow boom. Let's go. Is that working? There we go. I see you, Glances. Why is he all the way over there? That's better. Okay, Glances is up. We're working on the ticker. So just updating the ticker, then we're going to jump into the hackathon. This is the official Kaggle Discord I have up in the top right screen corner for the hackathon. How many folks are on this on the challenge? 5,000 people. They're some of the most enthusiastic coders are here. If you guys looking for a team, let's put a post in here to see if anybody would like to team up. What's this? Right, a brief introduction for the Kaggle 5-day Google Discord section for joining a team. It's myself from California. Include my GitHub and professional background. If anyone wants to team up to solve a problem for a medical issue, I'm gonna be live streaming the process on my YouTube channels. That's gonna be good engagement. Oh, the song has just been repeating itself, really? Repeat all. Hermes agent cooked that up. We'll post that in the Discord. Oh, what's up with folks, man? Like some people are not interested in engagement much. I got a new mention. Trying to be a nice guy, chatting to people and sending messages, and it's like, oh, maybe you're a bot. There was no message, there's nobody there in the beginning to actually reply or have a chat with. Not totally frustrating, but a little bit disheartening. Put yourself out there and it seems like you're just speaking into the abyss. Hello. Let's get that ticker cooking. How are we doing with our request here? So I'm using Mimo, Xiaomi, version 2.5 Pro. Oh, we had an error. Failed to load messages. Maybe I'll update the web UI. This is the web user interface. I also use Slack, but Slack gets really complicated when you're digging through multiple chat threads. It gets really crazy. God willing, our ticker should be working now. There we go. We're back. Markets are open again. I lost my chat. Oh, here it is. Hey, come back. It's here, but... Oh, it's gone in the wrong... I thought I started a new chat. Come on, Hermes. I know you can do it. Do 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 do. I'm Raphael from California, clinical AI researcher with an MBBS, BSc background, deep into healthcare AI research ops, building automated pipelines, to team up on anything at the intersection of AI and healthcare medical problems, clinical decision making. I'll be live streaming the whole 5 days, so if you're my team to get some nice exposure while we build, should be a good time. Drop a message if you want to collab. Let's go. Let's make some friends. Looking for a team. I've got a Kaggle badge already, which is good. Okay. I need to be mindful of my time management to make sure I'm pacing myself appropriately. So we're cooking with gas. We've introduced ourselves to the team for the competition. I am going to take a quick break, have a snack for about 5 or 10 minutes, and then when I come back, I'm going to jump into the Kaggle challenge. I'll be right back, folks. started. I'm heating up some spaghetti that I cooked yesterday. I love spaghetti bolognese. I didn't have any Italian seasoning. I had lots of Middle Eastern Armenian kebab seasoning. So I made what I call kebab spaghetti. So it's the same as bolognese recipe, but the seasoning is the seasoning used for shawarma. So let's get started. Today's assignment. Complete Unit 1, Introduction to Agents and Vibe Coding. Listen to the summary podcast episode for this unit. To complement the podcast, read the new SDLC with Vibe Coding white paper. Complete these code labs. Get started with Anti-Gravity 2. Build a web application in AI Studio and deploy to Cloud Build. Transition from manual syntax coding to intent-driven vibe coding. Disciplined agentic engineering. There was a live stream earlier, but I couldn't catch it, so we'll watch the replay. Sounds like a good start.
Anand, why don't you come on and introduce yourself?
Thanks. Great to have you here, Smitha, and welcome everyone to your first live stream for the fourth iteration of this course. I'm very excited to have you and guide you through the rest of the week.
So this is only 50 minutes, so we'll watch this.
I'm glad to be doing this with you, especially given how much has changed in the way that developers actually build software since the last iteration of this course. Quick ask before we get started. Drop in the YouTube chat where you're joining from. We're always really curious to see the spread of everyone.
I'm live streaming this under the principle of education and adding value to the program. So this content should be protected under the Fair Use Act.
Quick overview of this week. So throughout the week, you'll get white papers, companion podcasts, which were honestly one of the most popular formats last time because they made the most dense material easier to absorb. You'll also get hands-on code labs, daily live streams and AMAs just like this one, and an optional capstone project at the end where you can compete for Kaggle certificates, badges, swag, and recognition across Kaggle and Google's social channels. So if you have registered, the content will land directly in your inbox. If not, everything is on the Kaggle Learner portal, and it will be announced in Discord as well. Also, before we move on, quick thanks to the people who put everything together, the Google researchers, the engineers who wrote the white papers, the speakers joining us this week and today, and the Discord moderators who have been answering questions nonstop. The mods have been a great resource during this week.
And the awesome Kaggle team as well.
Yeah, definitely. Let's actually get into day one topics, right? So the reason this course exists and the reason we're running the fourth iteration of it is that the way software gets built has fundamentally shifted. So as of early 2026, 85% of professional developers regularly use AI coding agents. And roughly 41% of all of the new code is actually AI generated. So that's not just a future trend, that's actually the current baseline, right? So the gap between prompting a model and building something that you can actually deploy to production is where most teams are actually stuck right now. And that's what we're going to be working through this week. So here's how this entire week is structured. Day one today, we're going to be covering introductions to agents and vibe coding. So we'll cover the shift from writing syntax to expressing intent, the spectrum from casual vibe coding to disciplined agentic engineering. And then you'll also get to vibe code your very first app using anti-gravity and AI Studio. Anand, why don't you walk us through the white paper?
Thanks, Smitha. So everyone, hope you had a chance to go through the white paper for SDLC with vibe coding and how it changed. So in today's white paper, you would have looked at how we are at the most profound shift in computing history, transitioning from translating syntax to expressing intent via natural language. We also explored the spectrum of development from casual vibe coding, quote unquote, where you prompt an AI and copy-paste errors back to iterate, all the way to disciplined agentic engineering, as I like to call it, where AI operates within structured, deterministic boundaries. We also broke down context engineering, which is the real skill of modern engineering. You also learned the difference between expensive static context, like system instructions, versus cost-efficient dynamic context, like agent skills, loaded on demand. More on that in day 3. Day 3 is all about agent skills.
Looking forward to that. That's going to be great.
This shift fundamentally alters the software development lifecycle as we knew it. In this new SDLC, the implementation phase collapses from weeks to potentially minutes, making requirement specification and verification the new human bottlenecks. Now, later on in the white paper, we looked at the factory model of software development. And as developers, our output is no longer just raw code. It is the system that produces that code. We also introduced a critical formula for the system, which is agent is equal to model plus harness, where the model alone plays only around 10% of the equation, and close to 90% is the harness, which contains the sandboxes, the tools, the orchestration, and the guardrails that makes the whole agentic coding system reliable. Finally, we discussed the developer's changing role, and we looked at how developers find themselves moving between conductor mode, directing real-time edits in the IDE, and the orchestrator mode, which involves them asynchronously delegating complex tasks to autonomous agent networks and swarms. We also have some great code labs and a lot of exciting materials for the rest of the week. Fran will be covering the code lab later, but off to you, Smitha, for our guest Q&A.
Awesome. Thanks, Anand. And also a quick tip for everyone. If you haven't already, listen to the podcast first and then read the white paper. The podcast does a good job of framing the why before you hit the technical detail, and then the concepts actually stick better in that order. All right, let's head on into the Q&A. Let me bring up all of our expert speakers we have today. So we have Jamie from Cloud AI, we have Logan from DeepMind, we have Partha Sarati from Cloud AI, and we have Shubham from Cloud AI. So these are the folks shaping how this stuff actually ships at Google. So the answers you're going to get are grounded in what's being built right now. And thank you all for making the time for this. Anand, kick us off with the first few questions.
Thank you. Excited to have you all here. So our first question would be, this question is for you, Logan. So as development shifts to asynchronous orchestration, how do you see computer science education and hiring standards evolve to prioritize high-level architecture judgment using coding tools over syntactic coding mastery? Since quite a few of our participants are developers in the early stage of their careers, or even some students, they would love to hear about this.
Yeah, it's a really interesting question. I mean, there's a huge amount of discourse happening right now about sort of like how computer science education is going to change. I think the thing that makes me very optimistic, despite like what I assume is going to be like a very reasonable amount of change of like how those programs adapt and things like that, is that computer science education has always been about how to think, not how to like type keys into a keyboard. And I think like historically you sort of had I think about, like, as I reflect on my own computer science education, there was sort of like two tracks. It was like, all the, architectural decisions, the sort of like logic, how algorithms work, et cetera. And then you separately had the like applied version of that, which is like, what is the Python syntax that I need to know in order to like actually do something useful? It's interesting actually that you would like intersperse between the two things. In a lot of cases, you would learn algorithms and then you would try to apply them. And I think there's obviously the applied form of this is going to continue to be super useful because as sort of like a way to express your thought. And sort of the analogy to this is like, we've obviously had calculators for a very long time, and yet I think it's sort of universally, or at least mostly universally agreed upon, that like learning how to do math is still important to do because it sort of forces you to express the mathematical ideas in practice. And so I think as we turn this corner where like now code can be written in large quantity by AI systems, and you sort of don't need to do that yourself. The thing that I'm excited to see the change around is like actually people coming out of the educational institutions and infrastructure with not just like a college degree or some sort of like proof that they know something, but actually like an entire system or an entire business that they built during that process. And I think there's like a really interesting, again, like more akin to sort of like a trade craft that I think people are gonna like, when you do trade crafts, you go and like do some of the field work and in actual practice. I think seeing that for computer science, I think would be really interesting, where like you come out, you have a business, you have proof of work, you can like validate for agency and all that. So I'm excited to see, and obviously like all the technical details.
I better just check with the Kaggle crew that they're okay with me live streaming.
Logan, so,
if I get their blessing, that'll be great.
How do you think
if not, I might have to take some of this offline. Let's see.
Are there a couple of tools or technology you think that you would recommend to the audience here?
Yeah, I mean, this is the direction that we're going. Like, we're very much trying to like not only ride this wave, but like help make sure that students and people who are trying to build these types of businesses can make it happen. So I think I talk to the team about this all the time. We've done prompt to prototype. That's like pretty reasonable. We've done prompt to production. Like you can send one prompt, build or many prompts, and then build a fully functional website and deploy it and share it with the world. And it's like very obvious that the next step is we say like prompt to profitable company, because it's not just about like building a company. It's actually about like how do you get people to actually use it and find product market fit and get your first users and do that sort of the total iteration of the experience. And so we're working on lots of stuff in order to make that possible and actually like let everyone in the world have a business. And I think it'll be the optimistic version of this is it's very similar to what YouTube did with creators. Like prior to YouTube, you like couldn't, it was really difficult. You had to like go convince a TV network somewhere or a radio network to tell your story. And it was like the means of storytelling was controlled by a few. And then YouTube came and everyone could tell their story. And I think software is going to be that same exact thing. You used to have to hire many, many developers and have a big business and raise money and do all this stuff. And I think now everyone's going to be able to build a software business, which is really exciting.
Amazing. Thanks a lot, Logan. That was, and hopefully everybody is listening to that, because we have a lot of cool stuff coming. Amazing. On to our next question. So talking about building businesses from prompts, Partha, this question is for you. Given the recent advancements in self-evolving AI for coding, how do you see the exciting advancements by DeepMind brought into cloud, by technologies like Alpha Evolve? How do you see it helping technological breakthroughs across the industry?
Yeah, thank you for the question, Anant. Alpha Evolve, for those of you who haven't heard about that before, is a evolutionary algorithmic agent. And what Alpha Evolve does is it uses Gemini or any large language models, and it uses an evaluator function, and it identifies optimized algorithms for any use case. And initially, when Alpha Evolve was introduced a year back, we showed how Alpha Evolve could solve decades-long math problems, things like matrix multiply, which were been optimized, and Alpha Evolve was able to come up with new optimizations. we've shown how Alpha Evolve can be used in a whole bunch of different use cases within Google as well. For example, how we build large-scale schedulers, how we even use it to design new hardware and so on. And what is very interesting about these kind of self-evolving agents is when you're starting to use agentic vibe coding or agentic engineering, as Anand called it, these become a tool in your arsenal to start optimizing the algorithm. So you don't need to really think about how do I get to better performance. You can use this as an additional skill that you can then optimize. And in the last year, I've just been blown away by how we've used Alpha Evolve across a spectrum of use cases. We've used it in science, things like DNA sequencing or molecular simulations. We've used it in cloud. And again, cloud, we've used it in financial, retail, a whole bunch of different use cases. And we've also used it in infrastructure. I have personally used Alpha Evolve in some work I've been doing around optimizing new computer architectures. And so the opportunities really are incredibly profound. And so think of this as you have an expert optimizing agent at your fingertips as you go through your vibe coding journey.
Found that super exciting how everything can be done just by the means of prompting. So you write your initial code with prompting, as Logan mentioned, prototypes, even production ready, some of the systems. You put that in production to cloud, and then you can optimize it for technological breakthroughs and take it a level higher with another system like Alpha Evolve. Really exciting times to be living in. All right, to our third question. Smita, yes. So this question is towards you, Jamie and Shubham. What architectural patterns and cloud products are proving most successful in helping autonomous agents cleanly cut across the final context-heavy 20% milestone of a complex task with ideally minimal human intervention?
I can start.
Okay,
Oh,
go ahead, Shubham.
I would just take a step back here and go back to the first question that you asked, Logan, and just want to point out that we are living in a very exciting world where engineering power is pretty much abundant and unlimited. Everyone has that at their fingertips. You just go in and fire up AI Studio, fire up an agent, go and use Gemini. You have all of that at your hand, at your fingertips. The things that are becoming really, really important is understanding your core problem, being able to communicate that to an LLM, to an AI agent, and be able to verify the output that it generates. Now, mapping those skills to the scaffold, build, observe, and optimize loop for agents is what really helps you go from the 80% vibe coded part to 100%, that 20% missing part, Anand, that you're talking about. And the good thing about it is we have actually mapped that journey here at Google for you. And the day one white paper and the entire 5-day course really owns in on that. So you start with building an agent in ADK. You can go and evaluate it on agent platform, deploy it on agent platform. You can have the traces coming out, and that gets optimized. So what you're essentially building is the entire loop. And on top of that, when context becomes heavy, you have this concept of agent skills, which helps you dynamically inject context when the agent needs it and not have it bloat the context. So that entire loop plus agent skills is what really helps you get to the 100% or to cross that 20% gaps to make your agents work reliably in production.
Yeah, I think that's great. I think this is a great question. I think, that last mile is really what is often the biggest challenge. If we're moving from prompt to prototype to prompt to production deployment of a website that you're sharing to like actually using something to run a business on, that last mile of quality and ability to do the task really consistently, handle error cases is
my microwave
often
pinged.
the
I'll be right
challenge.
back.
And so I think
So far, so good. Very cool. I'm back. Had some nice spaghetti. Now I'm ready to learn.
Having a full tool set to help you evaluate, have verification tests, have long-term memory across sessions, have the ability to optimize in production and learn automatically to improve the quality over time. A lot of that is what becomes necessary to really close that last mile. I think a couple things I would add to that, part of this is around architectural patterns and what's been successful recently. And I think two things I would call out are, first, using agents to write code. And so instead of just an agent being something that is a set of LLM calls with a custom prompt and some context and maybe some tools available, moving to something where you're giving the agent a sandbox environment to write code, create its own tools on the fly, create sub-agents, which evaluate the work of the agent and evaluate the code that's being written. I think that pattern's showing much more success than just having an agent be a set of LLM calls with custom context. The second piece in there, I think, is really around the verification loops, both automated verification loops, so having a sub-agent that evaluates the work and iterates, but also having a human-in-the-loop step. So a set of conditions that flag for human-in-the-loop verification or review, and then creating a data set from that verification that can allow self-improvement over time. Those are some of the things that I think we're seeing a lot of success with to kind of close that last mile.
I think evaluation and a curation of golden data sets from that human loop is definitely something which we need to focus a lot on as well. Thanks a lot, Shubham and Jamie, for your view on this. And Smitha, let's go on to the community questions.
Thanks, Shubham. Thanks, Anand. Really great signal in all of these answers. I also want to add on to what Shubham was talking about on agent skills. So day 3, we'll be covering agent skills, and we have an entire white paper which is coming out on agent skills. I'll also be leaving a link in the description box to Google's skills repository as well. Let's actually move on to the community questions now. So the first one we have from Deplina Carr, and this is directed at you, Jamie. So what are the primary long-term risks and potential failure modes of using an AI-driven software development lifecycle, as opposed to its widely discussed benefits like cost reduction and increased productivity?
Yeah, great question. I think first I would say I'm incredibly optimistic here. I think that our ability to adapt as humans in general, but also as technical innovators, is really high. And so I think that how we do that is by thinking about the risks and planning for them and auditing them as we go. But I am very optimistic. I think some of the biggest risks of moving to an AI-driven SDLC, I think, are first the erosion of the human expertise, specifically with that code base. So I think we should assume the AI is going to be very successful at writing code, at evaluating it, testing it over time, responding to issues and fixing them. And assuming a successful path with that, what will happen to the developer or architect's expertise with the code base? You know, more and more of the code base will be written and managed by the AI. And so we'll have this sort of erosion of that human expertise with the code base. As that happens, how much ability does that human have to actually properly orchestrate and direct the AI and ensure that, you know, things are architected well for where we want to be going in the future, drive the improvements that are needed, you know, resolve issues when they come up, etc. I think that sort of leads into the second big risk, which is really around the accountability that happens when there are issues. You know, if we become less expert with the code base, the AI really is successfully driving the code base and resolving a lot of the issues. How do we manage accountability when issues come up, you know, between which employee or architect or engineer is responsible for issues as they come up? And then I think the third risk is, you know, with both of those things happening, there could be lost opportunities for improvement. I think a lot of the innovations that engineers have really come from a depth of understanding of what's happening in the code base or in the product. And so if we're not careful, we may have a lost opportunity for further improvement. Obviously, the AI will come up with some of its own opportunities for that. But I think that the engineers' ingenuity and opportunity to come up with those may be lost if we're not careful, if we drift too far our understanding of the code base. And so I think those are the risks. If we're careful, we can plan for those and come up with ways that we ensure that we don't have that erosion of expertise or drift in understanding over time.
Fantastic insight. Just one thing more which I wanted to add on to Jamie. I also think if we lose that technical expertise over time, the security gaps and risks that get exposed as well, which we'll be covering more in our day 4, would also become even more pronounced than they are as of today. Just that kind of is something we should maintain good control of and knowledge of our code base for.
Yeah, totally. Good insight. I agree.
Awesome. Okay, let's head on to the next community question from Christoph. Can we combine the open knowledge format with a localized graph RAG architecture to let agents map and iterate on full system designs at a semantic graph level before writing code? And I think, Shubham, you'd be a great one to answer this.
First of all, it's a great question. So we recently launched open knowledge format, which is based on Karapathy's neat idea of LLM Wiki. So the beauty about it is how simple it is. It's just a set of markdown files that links to each other that you can have in your system. And each markdown file is representing a thing. It could be a service, could be a database, a contract, whatever. And the nodes link to each other. That's it. It's plain text that you can read and the agents can read as well and can edit it. Now think of these as index cards on a board with strings connected to each other. These are like markdown files that are connected to each others, representing some entities. And you're asking, the problem that you're essentially talking about is, can I combine it with graph RAG so agents can actually have the map of the entire system or the whole system, the entire repository, before it even starts writing a single line of code, which is a pretty neat concept because what happens is when you fire up an agent in a big code base or a GitHub repository, it usually jumps into straight writing the code without really looking at the entire context. Now, you have open knowledge format, combine that with graph RAG. Graph RAG, what it does is follows those strings between cards. So it actually understands how the connection works. It can answer if I change X, what gets affected. So if I change this specific card, this markdown file, what gets affected? And it can look at those connections. So I think it is definitely possible to combine graph RAG with open knowledge format, which could be a pretty neat concept to solve the contextual problem for very, very big code bases. And it could give the agent right context, not just about what all exists, but also about the connections between different files, the connection among your code bases. This is more or less like mimicking how an AI architect or AI engineer would go about writing code. It's not about just changing one file. It is also an understanding of if I change X, how that would impact my entire code base. What breaking changes would that introduce? So I feel this is a very interesting concept that could be definitely explored and would be like super interesting.
Nice. So it almost seems like this is really a context engineering question. Like, how do you give the agent a structured representation of the system that's denser than just kind of dumping the whole repository into the context window, it seems.
Yeah.
Awesome.
I love this. I think we have our first roadmap request to add here from the week. This is great.
Great. Okay, moving on to the third community question from Adam. So this is directed towards you, Logan. So about the autonomous agents, what are reasonable use cases for long-running agents?
Yeah, it's a good question. I think maybe some of the historical context for this is, I think if you look at like what was Google's first successful long-running agent, it was deep research. Deep research, I think, was the first thing that we sort of released into a consumer product, and then ultimately it's actually available in the APIs as well, where you can actually go off, do sort of an autonomous research loop, come back, create a bunch of artifacts, and provide them to a user. And so I think we learned a bunch of stuff about that. I think the second one that's like more widely ubiquitous is around AI coding, obviously. There's something interesting about both of those use cases, and I think why they've actually worked well. I think in the context of deep research, you're oftentimes the answer to the question is not like a finite thing. It's like, in some cases it is, where you're traversing the internet and you're sort of trying to collate like a very specific answer. Oftentimes there's like all of this like scaffolding, contextual scaffolding that you need for the answer to be relevant and make sense. In the context of autonomous coding agents, which I think are the most, maybe from a token consumption these days, like probably obviously the most predominant long-running agent, the reason that those systems can work so well is because they're actually like continually testing and being verified. And this is the balance of long-running agents today, is you don't want the agent to go off and do a bunch of work and basically waste your money and time, and then ultimately it didn't do something productive. And so in the case of coding agents, you can sort of like continually run the code and make sure that the incremental additions that are happening aren't breaking a bunch of stuff or sending you down the wrong path. In some cases that does happen still, and so the models get better over time. And then again, in the case of deep research, sort of it's there's sort of a peace of mind knowing that like I'm willing to let the model and agent run for a longer period of time so that it sort of truly covers the fullness of the ecosystem. I think there's definitely other use cases that are successful. Those feel like the two most successful right now. And I think the interesting thing to think about, and I had this conversation with Jeff Dean a few weeks ago around sort of like, as the models become longer running, you start to see a bunch of like really interesting new bottlenecks come up, which I think is actually like more correlated to the use cases than I think you would imagine. And so if you're thinking about like what problems to be solving, or as you build long-running agents, like where to look to go and find alpha, it can actually be in the tools. And if you've ever like looked at a long agent trace, some reasonable amount of the time that the model spends, and this is going to be an increasing portion of the time, is spent just like using external tools. It's not actually the model answering your question or thinking or whatever it is. It's actually the model using external tools. And the challenge is that these external tools were not actually built to be used in this capacity. They're oftentimes like different systems that were assuming there was like a human interacting, so some latency would make sense, and like maybe a lack of parallelism would make sense, but that's actually not the case in agents now. And so I think we'll see all of these like weird bottlenecks show up as we make agents run longer. And I also think like as model capability improves, we'll see like a better diversity of like successful use cases. But it really does feel like coding. I'll be excited to see like some use case like dethrone coding. I think maybe it's like starting to become like at Google I/O, we launched Gemini Spark, which is sort of your always on 24/7 like personal agent that can even throw tasks over the wall and it'll do. So maybe that use case over time, just given the volume of people who are needing a personal assistant versus coding, maybe that will dwarf it from a token consumption perspective. But it feels like coding agents is by a long shot the biggest use case today.
Yeah, agreed. I also feel like, you know, stuff which takes humans a long time to do are the best use cases for long-running agents. So research is definitely one of them. We also have an episode of the Agent Factory where we go into 3 different use cases of long-running agents, which I'll be leaving in the description box below. And we have a blog post released by Google Cloud, which shows you exactly how you can build a long-running agent example from 80K, and that will be in the description box as well.
Yes. Thank you, Smita. And talking about use cases on long-running agents, I fully agree. There's a lot possible. Coding is one, Deep Research and Deep Research Max, which is my personal favorites as well. But there's also stuff like Co-Scientist and Alpha Evolve, which are like super long-running agents. And the longer you run them, the better the quality. And then also another thing, which I think used to receive a lot of attention in the last iterations within this course, but less so now, is multimedia. Like Thomas Pfister from our Cloudera recently published a paper around how you can make longer movies, more than just say 20 or 30 seconds, with an agentic long-running agentic system, combining a lot of the best practices around eval and agentic engineering as well. So yeah, really looking forward to what comes up.
I think another thing I'd add there is if you think about a dynamic environment where inputs are changing, long-running agents can often be well suited. So for example, banks processing loans, a typical loan process in a bank may take weeks to a month to approve, and there's different inputs that the agent needs to go back to the employee to get more information and process and change the dynamic decisions based upon that. Insurance claims, a legal agent working on a court case, the input information changes dynamically, and you need to have that ability to have the agent be long running to continually dynamically adapt to the different inputs.
Jamie, I think this would actually be something interesting for the cloud team to map, which is like you sort of have the length of how long the agent can run for on the sort of x-axis, and then over time as it can run for longer, you actually see all of these additional markets and different segments unlock. Because I feel like there's a lot of things where actually, maybe for the example would be one bank, choose your favorite bank takes, they need 30 days, but the other one maybe needs 60 days or something. And so it doesn't work now for the bank that needs 60 days, but it does for the one that can do it in 30 days. So it'd be interesting to see and track that over time.
Logan, I think cutting out, but I believe talking about different long-running use cases across different industries makes a lot of sense. I believe yeah, as an industry, there's some use cases which the longer you run the agent, the better the output, and you can see that in many industries. Shall we move on to the next question, Smita?
So we have a community question from Sayan, and he's asking, could you share some real-world examples where vibe coding has been applied successfully? And what challenges developers face when moving from chatbots to fully autonomous systems? Partha, would you want to answer this?
Sure. Thanks, Sayan, for the question. It's actually a pretty interesting question. I think it's actually 2 questions in one. And I could probably spend a lot of time talking about both of those. So the first part is where are we using vibe coding? I think Smita mentioned earlier a good fraction of code. The last time I think we talked about it was 75-80% of code at Google is developed using AI. But I think I have been particularly lucky to work on a whole bunch of applications, and it's just been amazing on where you could use it. AI for coding, of course, but you can think about AI for system development, AI for performance, AI for efficiency, AI for reliability, AI for operations. You can think about AI for supply chain management, AI for productivity, AI for science. So I think the applications for AI are just phenomenal, and across the board, you could apply it in various different ways. If I had to pick one example, we recently wrote a blog post where we talked about how we've been using AI to automate migration from TensorFlow to JAX. And as you can imagine, these kind of migration problems are incredibly hard and they're very time consuming. And we were able to use an agentic approach to automate this in a way that got us on YouTube, for example. When they did their TensorFlow to JAX migration, we were 6 to 8 times faster. And you can imagine the amount of time that you can save by doing something of this sort. And maybe, Smita, we can put a link to the blog post that we wrote about this later on as well. So that is all the various applications for AI, but really, I think you're just limited by your imagination and where you can use vibe coding and agentic engineering to try to do stuff. Now, in terms of some of the challenges, we've already alluded to a few of those. Jamie mentioned some of the things around how we want to think about safety. And I usually think about the 3 H's, hate, harm, hallucinations. And so you want to obviously make sure that you're grounding, you're thinking about bias in the data set, you're thinking about the safety aspects of how all of the AI works. And Anant mentioned evals, and we're going to have a whole section on evals, I believe, in one of the days here. And thinking about security and verification and hate, harm, hallucination, super critical. The second observation I would make is similar to what maybe Logan talked about. You really want to think about the entire workflow. So especially when you think about long-running agents, it's very easy to optimize one portion. And I think of the old children's game of whack-a-mole where you can hit one thing and something else pops up. And so you have similar problems here where if you just optimize one, for example, if you're thinking about optimizing coding and you optimize coding by 10x, testing becomes a problem. And so you really want to think about what does AI-infused workflow look like? What does the entire journey look like and how you can optimize for that? And so that's a challenge and a lesson that we have learned in terms of how, as you start having vibe coding and agentic architectures, you want to think about the full workflow and not just optimize one portion where something else becomes a problem. The third challenge I would observe, or at least I have been observing, is thinking about, again, the life cycle of how you apply AI. I have this framework that I call I, U, us. And I stands for impressive, U stands for useful, S stands for sustainable. And what I usually talk about is oftentimes when you're using vibe coding, agentic engineering, the first demo that you come up with is impressive, so the I. And that's always where you start off with is you take a specific use case, you build something really nice, and that's always a good starting point. But then you want to go beyond that to saying, beyond that particular use case, how can I make it commonly applicable? So something worked for me, but how can it work for everybody else who is using it? And so you go from impressive to useful. And then once you get useful, you want to think about how this is scalable, secure, sustainable, and that's the S part. And when I say sustainable, oftentimes I've seen people come up with an AI use case that can be 3 times more expensive than the regular current way of doing that. And it's, of course, AI. But what you also want to do is to start thinking about how can you be sustainable about how you use AI as well. And so that's the other lesson we are learning is as you navigate the vibe coding agentic engineering journey, you want to think about, are you in the impressive or the useful or sustainable stage? And it is a journey and you go through all 3, but you do want to ultimately get to the sustainable, scalable solution that helps everyone else and so on. And so that's something to look at. But I'll go back to something that Logan said. Ultimately, this is a new paradigm and we are all learning together. And I'm sure you're going to have a lot of lessons as well. So the most important thing is to be adaptive and be nimble about what we are learning and be aware that it's a new paradigm and that we're going to be learning things as we go along. But hopefully the 3 observations I said were useful to you folks as you think through your journey as well.
I love the acronym IUS. I feel like I could use that, even when I'm picking up a skill or something. Is this impressive, useful or sustainable?
And sustainability is one of the reasons why, for those of you who will be facing quota quota restrictions in the code lab throughout the week because we have limited quota for free usage. So this sustainability is a part of that.
Awesome. Thank you to all the guest speakers for coming on here to answer all the questions. This was super helpful. Now, all right, we're going to start actually moving on to the code labs. And today's code labs, there's 2 code labs which are designed to actually get you hands-on with vibe coding from minute 1. So Fran's actually going to walk us through both of them. Over to you, Fran.
Thank you, Smitha. Hi, everyone. Wow, what a good discussion. Welcome to the Code Labs for day 1 of our code. I'm Fran Hinkelman. I lead the AI DevTools team in Google Cloud DevRel. And I'm so excited to guide you through your first steps of agentic development. For day 1, we have 2 practical code labs that will get you up and running. First, we'll introduce you to Google Anti-Gravity, which will be your main tool for the whole week. And second, we'll look at Google AI Studio as another option for building apps, how to publish them, and how to share them with all your friends. In your first code lab, you will install and configure anti-gravity. Could we share the screen? Yes. So you'll install anti-gravity. It's your central command center for managing your agents, your workspaces, and your code. And once you have it installed, I encourage you to work through the code lab, click around, and explore. It's a very visual way to partner with your agent. You'll see how they create implementation plans and guide you through the tasks. You'll see your artifacts on the right here. You can open the IDE. If you want to try out different models, you do that right here where you set your prompt. And one thing I want everyone to look at is if you go to settings and then to models, then you can see your remaining token quota. And if you run out of Gemini tokens, you can always pick another model, Claude or GPT models, right in your prompt. That should get you about twice as far as what you've used so far. All right, so let's look at the code labs for day 1. Let me share code labs. So as I said, first code lab is about Google Anti-Gravity. The links to the code labs, those were shared with you in your welcome email. They're also in the discussion post. So go to those links. You don't need to log in or anything for code labs. As you work through your code labs, you can go back and forth. There's no time limit or anything. There is a time right here. It's just showing you how long you sort of of expected to complete it. But you can work on those infinite time. There's no timer ticking or anything. And then our second code lab introduces Google AI Studio as another option to build labs. And you already heard Logan talk about AI Studio. You'll learn the basics of how to vibe code an app by describing it in plain English or any other language. I built this very silly corgi app here in the impressive, useful, sustainable. It's maybe
cool.
in the impressive part, it's definitely not in the useful part.
That's cool.
But we'll show you how you can build any app and how you can publish it to the cloud with just a few clicks. I'm super excited to see what you're all building on day one. Once you have your vibe-coded app deployed, please, please, please share it with us. Drop the link in the Discord server. Like, we're all here to learn from each other. And I'm sure you'll do something way more impressive than my corgis jumping around here. After you finish a code lab, work through them. I really encourage you to carefully read between the steps. Don't just copy and paste the commands. You learn the most if you actually read it to understand it. All right, so that's all for the day one code labs. Have fun with the labs, share your impressive apps, and back to Smitha.
Awesome. Thanks, Bran. Both those code labs actually look amazing, and they're super worth running end to end. And the AI Studio to Cloud Run one is particularly such a concrete example, like going from idea to a deployed URL in minutes. That used to be a multi-day setup. Now you can do that in minutes. So now for arguably the most exciting part of the live stream, the pop quiz. Off to you, Anand.
Yes, I would say it's the second or third most exciting after the Q&A. But for those of you who have been listening and reading the white papers, we start off with our first question of the pop quiz. So your first question would be, every AI agent is built from 5 parts. Which part is described as the reasoning engine that reads the context and decides what should happen next? Your options are A, the memory, B, the tools, C, the model, or D, the orchestration. Think about it, and your answer will be shown in 3, 2, 1, and C. C is the main brain, the reasoning engine that powers your AI agent, especially for AI coding agents. Moving on to the next question. Which of the following is a key differentiator of agentic engineering compared to the casual vibe coding on the development structure? Your options are A, minimal code base understanding and selective review, B, sole reliance on manual spot checking and user prompts, or C, a systematic process of testing, CI/CD gating, evaluation judges, etc., or D, copy-pasting raw error message back to the LLM tool so that the LLM can resolve them.
C.
Your correct answer will be shown in 3, 2, 1, and it's C.
Yeah,
Agentic
got it right.
engineering is a systematic verification through automated test suites, CI/CD gating, and evaluation judges. Moving on to our third question. According to our white paper, or day one white paper, what becomes the primary new bottleneck in the compressed AI-driven software development lifecycle? Your options are A, designing the database schemas, or B, writing the boilerplate syntax to bootstrap the process, C, running code in isolated sandboxes, or D, specification quality. Your correct answer will be shown in 3, 2, 1, and it's B. So whenever, given the power that AI has, being very, writing your specs to a lot of higher quality, which you also see in day 5, becomes a big bottleneck to make sure you build the right things. Question 4. So in this equation, what constitutes the missing harness component? agent is equal to model plus harness, as we saw earlier in the white paper overview. What is that missing component? Your options are A, the physical GPU infrastructure holding the LLM, the custom trained weight matrix of the transformer model, or whichever model, diffusion model that you use, C, the surrounding scaffolding, or D, the function of memory storing long-term user preferences. C is the correct answer, because that's what the harness is. The model powers the harness and vice versa. Pretty important part. All right, to your last question. Our last question is, what financial and operational trade-off describes the investment of in agentic engineering? Is it option number A, low capex, high opex, B, high capex, low opex, or C, low capex, low opex, or D, high capex, high opex? So think about it, and your correct answer will be shown in 3, 2, 1, and it's B. Agentic engineering leads to a higher initial investment, be it in your training your models, your GPUs, or setting up and using tokens, but it leads to lower OPEX, which is the actual developer time.
Yeah, that's for sure.
All right.
I'd rather spend a week working on automating something than having to do it
and also
100 times manually, even if it takes time.
Day 2 assignments will drop shortly, and tomorrow's topic, agent tools and interoperability, picks up right where today's left off. It goes deeper into MCP, A2A, and how agents actually plug into the outside world. So keep the discussion going on Discord. The mods are active, and also get started on the code labs if you haven't already. Try to actually deploy something to Cloud Run. It's actually really satisfying to see your vibe coded app live that you can share. And also hope to see everyone tomorrow at the same time. Thank you for being here.
Same time, same channel, different topic. See you, everyone.
That was a good webinar. Good job, Kaggle. Thank you, Google. So let's jump in. I'm gonna open up my email and get started on the coding project. Just got my email over in another window. Dun 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 dun. My key take home from that webinar was IUS. Is it impressive? Good talk about sustainability as well. There's no point jumping into something that could be AI heavy just because it's the in thing right now, only for it to cost more than the actual gold standard. Especially with the cost of compute and the cost of tokens. With most systems getting more expensive. No point in breaking the bank. So complete these code labs. Get started with Anti-Gravity 2 and IDE. Let's go. "55 minutes. Code lab, you'll learn about Google Anti-Gravity, an agentic development platform designed to help you develop in this era of agents. Install Anti-Gravity. I've already installed it. Which one are you? Oh, maybe that was the wrong one. That was the IDE. So the white one is Anti-Gravity, the black one is IDE. And Anti-Gravity is like the app version of Gemini, kind of like Codex. My dad was using it. I haven't downloaded it yet. I've been pretty satisfied and content with the tools I've been using. Didn't see a need to jump ship just yet, but this is a good start today. like my video encoder is on fire. Sometimes I like to do a reboot before starting a live stream, and I didn't do that today, so that could be why. Nice. Anti-gravity wants to use the microphone. I wouldn't mind speaking to my coding agent with my voice. That would definitely help. So we've run the installer. Log in with your Google account. Let's go. Continue with Google. Good, we've got the same screen. Security notice and data use. Yeah, I agree. Do what you need to do. Stick with the dark theme. And plugins. Plugins are packaged collections of skills and MCPs to help the agent in anti-gravity work with Google developer products. It's Firebase. Just pull everything down. Okay, this looks very familiar. Looks just like Codex. You should see the anti-gravity interface as follows. Okay. Install anti-gravity IDE. I have IDE. That's here. So let's authorize that as well. Continue next. Start fresh. Dark modern sounds good. That's cool. They have key bindings for VI. Get to the settings menu as we need. Okay. Let's understand the concept of projects. Project is a combination of folders defining the environment and the scope of your agent. Okay. Let's create our first project. New project. I already have a folder here for Kaggle. Security settings. Wow, that's amazing. There have been so many changes that the actual interface has changed compared to the training material, which is crazy. Create. Let's say hi. Hi. Hi, I'm Anti-Gravity, your AI coding assistant. Great. Yeah, I don't mind having notifications. It's not a bad thing. Give me a nudge when you're done with what you're working on. We have another request to get the news. What's the current news in and around Palmdale, California, which is where I'm streaming from? Pretty accurate. Yeah, there was a fire here. There was a brush fire on the weekend. They managed to contain it. That was pretty scary. We've got Juneteenth coming up, the High Desert Beer and Wine Festival, and then Family Movie Night. Okay, great. In our project, we started a conversation thread, and there's a series of messages. You'll see this conversation on the left side, okay? Let's do something interesting and give a name to this conversation thread. Let's call it Conv Introduction. To do that, click on the 3 dots. Choose Rename. And then click the plus sign. That's nice, so we can see the chat threads within the projects. That's pretty helpful. I asked it for Armenian sports news, and we have Armenia hosting the Davis Cup. Not sure. Oh, that's tennis. In soccer, some news about the Premier League. And then some accomplishments in lacrosse and judo. Rename this conversation to Com Sports News, okay? Project settings. When you create a project in Anti-Gravity, it inherits default permissions, which you can override specifically if you like. Nice. Ooh, literature search. That sounds good. Open Alex. Very good. Okay, next. Slash commands. Oh, we have goal. That's nice. Consider the browser command as an explicit command to launch the browser and ask it to do something. It requires Google Chrome and permission in Google Chrome to start a debugging session. Oh, this is nice. Let's have a look. Allow reading this URL. Always. This spawns a browser sub-agent that attempts to launch a debugging session with Chrome and asks your permission first. That's called schedule. If you like to set up recurring or one-off tasks, type /schedule. It's interesting. Made a Python script. Oh, that's nice. Take a break every 20 minutes. That's cool. Let's do that. Schedule tasks. New. Custom. So it's just a cron. Let's do 25 minutes. 1, 2, 3, 4. Add MCP servers. MCP has emerged as the standard to help connect agents to external systems. They play a key role in ensuring that the agent remains grounded in terms of your data and integration. Anti-Gravity supports MCP servers, both local and remote, and it ships with integration to several MCP servers. Okay. Go to Settings, Dismiss. Customizations. MCP servers. No MCP servers. Add MCP. Dart, Firebase, Go, BigQuery, Postgres, Looker, Knowledge Catalog, MCP Toolbox for databases, Oracle Database, GitHub, Neon, Stripe, Redis, MongoDB, Notion, all the good stuff. PayPal, Superbase, Postman, Stitch, ClickHouse. We'll add GitHub. We like GitHub. Install. Oh, you need a token. Okay, we'll do this another time. Next. Artifacts. Anti-Gravity creates artifacts as it plans and gets its work done. It's a way to communicate its works and get feedback from human users. These are rich markdown files, architecture diagrams, images, browser recordings, code diffs, and so on. Task lists, implementation plan, walkthrough, code diffs, and screenshots. I like that. Create a conversation with a new or existing project with the following prompt. Write a Node application that I can run from the command line to get me the latest news from Google. Okay. Let's go. The agent takes off and comes back with our first artifact implementation plan. Let's have a look. We will build a command line tool in Node.js that fetches and displays the latest news from Google News. Since Google News does not provide a free direct API, we'll fetch its official RSS feed. Oh, that's nice. I didn't know we had an RSS feed for Google News. Proposed features: top headline, search queries, topic feeds, clean terminal UI and clickable links, tech stack and dependencies, Node.js, fast XML parser, Pico colors, minimist, or commander, proposed changes, package JSON, index.js, verification plan. Let's go. Let's go, let's go. I'm used to running my agent in YOLO mode, which is like full access, fully auto. Don't ask me for any permissions, just do it. Obviously the problem with that is it can cause a lot of chaos if you don't have a very strong command over how you've instructed the LLM or the coding agent. You can literally just do anything. As it goes to work, it creates another artifact task plan. You can see this in the auxiliary pane below. Where is the auxiliary pane? Am I missing something because my window isn't? Am I missing something here? I don't think so. Click on the task artifact, you'll see a step-by-step task list. That's nice. So the agent is working away. Working away, working away. My big concern is how long will it be before I hit a rate limit, because this is obviously the free tier of Google Gemini, and I know the provisions have, if anybody knows who's been vibe coding over the last year or so, the amount of tokens you're getting in the free tier are getting less and less, and it seems like you do a couple of turns and then you get timed out. That would be a shame if I hit a roadblock there, but we can always come back tomorrow. Okay. This is very codexy, if that's a word. Looks just like codex. I guess this is the new normal for non-terminal user interfaces. That's nice. I didn't know I could use a Google News command line interface. I might spin up a news page, have it as a live stream. Okay, great. Next. You can opt to use the anti-gravity IDE. If you prefer an IDE, you'll notice that when you go to the auxiliary panel in the main anti-gravity interface, there is an open IDE option. Click on that to open the anti-gravity IDE. You might see a warning. Okay. Okay, so it's VS Code. Yes, exactly like VS Code. Okay. While anti-gravity's models are powerful generalists, they don't know your specific project context or team standards. Loading every single rule or tool into the agent's context leads to tool bloat, higher cost, latency, and confusion. A skill is a specialized package of knowledge that sits dormant until needed. Yeah, this is what I've been using with a lot of my recent projects. I've been breaking real-world workflows into atomic skills and then calling those skills, and I've been doing them. Hermes has been great at doing that as well. Skills are directory-based packages. You can define them in two scopes. Global scope, product scope. I like that. Yep. Create a directory in the project folder that will contain the skill. create a new skill MD. Where are we? Agent, skills, code review. When reviewing code, follow these steps. Correctness, edge cases, style, performance. Save that. Let's validate the code review skill. Open a conversation and provide the following prompt. It should show the code review skill. There it is. Code review. Review code changes for bugs, style issues, and best practices. Nice. Create a new file called demo-badcode.py. Open a new conversation and give the following prompt. Review the file. Oh, we have a hit. Here is the code review of the demo-badcode.python. Correctness and edge cases. Guaranteed crash. Since the users list only contains IDs 1 and 2, get user data returns none. It will automatically crash. Okay. Synchronous blocking, input output. Linear search time complexity. Style and conventions. Inconsistent indentation. Naughty, naughty. Next. Congratulations, you've now installed anti-gravity, configured your environment, and learned how to control your agents. And we locked a new milestone. Learning has been added to your profile. Let's share that to LinkedIn. And we'll share it to X as well. If I can. There we go. Post. Nice. So I've done the first part. Next, build a web application in AI Studio and deploy to Cloud Run. Cool. I think that's a good spot to take a quick break, and I'll come back. Okay, thank you folks for letting me share my process. Gonna step away from the computer for a while. I'll probably jump back on again tomorrow to do the next day of the 5-day agent challenge. A good session today. I was streaming live for about 3 hours. We completed the first part. We set up Google Anti-Gravity, ran our first project, which was pretty good. To get news from Google, that's definitely something I've been looking to do for a long time. And what else did we do? We also fixed the ticker and the glances overlay, and got to watch the Kaggle show. So I call that a good start to the day, or a good start to the week. Hope everybody does well, and I'll be back tomorrow. So please like and subscribe if you haven't done so already, and take care of yourself. I'll talk to you soon. Bye for now.